Okay, so we're looking at logs and exponents today, and we have two exam questions here we're going to go through. So it shouldn't take too long. So the first one is solve 3 to the power of x is equal to 200. Now there's two ways you could do this. The first way is you could take log base 3 of both sides. So you know that if you have an exponent like this, if you have an x at the top, and you want to bring it down, you need to take logs of both sides. So one way you could do that is by taking log base 3 of both sides. So saying log base 3 of 3 to the power of x is equal to log base 3 of 200. And we know that due to our logarithm rules, if we have a power here, it's just going to move to the front like that. So we get x log base 3 of 3 is equal to log base 3 of 200. And we know that log base any number to the same number is just going to be equal to 1. So we know that this whole thing is just going to be equal to 1. So we can just simplify this to x because that's just 1. So x is log base 3 of 200, and you can work this out on your calculator. It comes out to be around, let's see, log base 3 of 200 is 4.82, and there's your answer. Now the other way you could do this, so let's use a green pen. The other way you could do this is by taking log base 10 of both sides, or you could do log base e as well, both work. So suppose you do log base 10. So I'm not going to write the base 10 because log by itself usually just represents log base 10. So log base 10 of 3 to the power of x is log base 10 of 200. Same thing again, we'll move the x down here. So we get x log 3 is equal to log of 200, and of course we can just go ahead and divide log 200 by log 3, and that should give us the exact same answer as this. So that's just a different way of doing it. You can use whichever way you prefer. I personally prefer this way just because I don't like working with logs other than log base 10 and log base e. But yeah, there's two ways to do it. So the second question, solve log base 5 of 5y plus 40 minus log base 5 of y plus 2 is equal to 2. Now when you have a question like this, what you want to do is have a log, one single log on both sides of the equation with the same base. So your final kind of steps of working should look something like this. Log base 5 of a is log base 5 of b, and the reason is because we can just go ahead and ignore the logs then. Excuse me, that was not meant to happen. Yeah, so we can just go ahead and ignore the logs and just focus on the a and b. So we want to make the equation something like this. So we've got two logs on the left hand side and no logs on the right hand side. So we want to get rid of one log here and add a log here. Well, you see the minus sign here, and that should indicate to you that we have to use the log rule. Log base or log a minus log b is equal to log a over b, and this is true for any base. So for base 5 it's the exact same thing. This statement here just becomes log base 5 of 5y plus 40 divided by y plus 2. Cool. So we simplified the left hand side. Now what do we do about the right hand side? We just have a number by itself. But what is 2? We can just rewrite 2 as 2 times 1. And that's the same thing, right? And remember what we said about log base whatever number to the same number being just 1. So we could rewrite this as 2 times log base 5 to the 5. Since this is just 1, that will just cancel and give us 2. So if we can rewrite this right hand side to say 2 times log base 5 to the 5. So we're almost done with our log steps. All we have to do now is bring this 2 over to the top. And all that means is that we have to raise 5 to the power of 2, which is 25. And I'm just going to do that here. So this becomes log base 5 of 25. And cool, we have the same log on both sides, one individual log on both sides of the equation with the same base. So we can get rid of the logs, we can just ignore them. And we have 5y plus 40 over y plus 2 is equal to 25. Now this is a pretty simple equation to solve. All we have to do is multiply both sides by y plus 2. So we get 25y plus 50. And we can just go ahead and simplify that. Bring the 5 here, we get 20y. Bring the 50 there, we get minus 10. So that means y has to be minus half. And that's it. So if you want to check your answer, you can just plug this straight back into the original equation and see if it gives you 2. And if it does, then you know that you've got the right answer. Cool. The next question. Given that this complicated thing is equal to this equally complicated thing, evaluate A, B, and C. Now, the thing with this kind of an equation is, because you want to find the powers, you might be tempted to use logs like straight away. And I'd encourage you to just think for a second before you start a question like this, whether using logs is really the best method. So we have a 27, a 12, and a 24 on the left hand side. And we want to decompose those into powers of 2, 3, and z. So what we know is that 24 is the same as 3 times 8, and 12 is the same as 3 times 4. So how could we rewrite this? We could rewrite this to say 3 times 8 times z cubed squared divided by 27, or we could rewrite 27 as 3 cubed, which is probably more useful here, as 3 cubed times 3 times 4 times z, right? So if we go ahead and expand out what we have at the top, this is just essentially saying 3 times 8 times z cubed times 3 times 8 times z cubed. So all we have to do is just raise each thing to 2, because we're saying it's 3 times 8 times z cubed times 3 times 8 times z cubed again, and the whole thing divided by 3 cubed times 3 times 4 times z. So if we just simplify the top, 3 times 3 is just 3 squared. So 3 squared times, so we can change 8 to 2 cubed. So let's just erase out the 8 here, and let's change the 8 into 2 cubed. 2 cubed, wow, that's a weird 3, and 2 cubed. Cool. So if we have 2 cubed times 2 cubed, that's gonna be equal to 2 to the 6th power, and z cubed times z cubed, same thing, z to the 6th power, and this whole thing again is going to be divided by 3 cubed times 3, but 3 cubed times 3 is just going to be 3 to the 4, so we may as well rewrite that as 3 to the 4 now, multiplied by 4 is 2 squared, and z is just kind of z. So that's pretty much our second to last working step. The final thing we want to do is just simplify out the powers. So we have 3's, 2's, and z's, and they all have their own powers. This is going to be z to the 1. So all we have to do really is use our log rules, or sorry, not our log rules, our exponent rules on each individual number. So for 3, for example, we have 3 squared over 3 to the 4. And if we use our exponential rules, then we know what we want to do is 2 minus 4. So we get 3 to the minus 2 multiplied by 2 to the 4 multiplied by z. Now 6 minus 1, remember the 1 here. 6 minus 1 is 5. And that's pretty much our answer. So the last thing we want to do is, let's go ahead and use the red pen. So the last thing we want to do is write it in the form they want, or just write the constants out, because they say evaluate a, b, and c. So a is the power of 2, which is 4. B is the power of 3, which is negative 2. And C is the power of Z, which is 5. Again, you can just go ahead and check this on your calculator. You can sub any number you like for Z on both sides of the equation, and you'll get the answer. Cool, so that's another question done. And this one is the last one. So you'll get a lot of these kind of without using a calculator questions in IGCSE Add Math. And don't get discouraged by it. All it means is it kind of wants you to work with surds, with things like 2 plus root 3, 2 minus root 3, and those kind of complicated things. So in this question, we've got this triangle, and what we want to do is work out the value of cos theta, not theta, cos theta. So you might be thinking that, well, it's quite easy. All you have to do is use the cosine rule, and that is what you have to do. But the thing here is that they're actually expecting to judge you on your surd manipulation skills. They're actually judging you on your algebra instead of your geometry here. So that's the hard part of this question. So let's go ahead and use the cosine rule on this triangle. We know that, what is the cosine rule? It's a squared is equal to b squared plus c squared minus 2bc cosine a, right? And actually I should be using lowercase, so it should actually be a squared is equal to b squared plus c squared minus 2bc cosine capital A. Yeah, there we go. So capital A is going to be the angle, so that's theta over here, and we know that this angle has to be opposite to the length. So let's say this is A, and you can choose B and C as this one or this one, either way you like. I'm going to say this is B and this is C. So let's use the cosine rule. We've got 3 squared is equal to, oh wait, I messed up the lowercase thing again. Sorry about that. This is A, that's B, and that's C. Cool. So 3 squared is equal to B squared, which is 2 squared, plus C squared, which is 2 plus root 3 all squared. 2 plus root 3 all squared minus 2 times 2 times 2 plus root 3 cosine of theta. Cool. So we can simplify this. We get 9 is equal to 4. Let's draw that more nicely. 9 is equal to 4 plus, so let's expand this out. If you want to expand out a surd, it's probably a good idea, if it's squared, to just write out the same term again, just so you can visualize it a bit better. So something like this. So 2 times 2 is just going to be 4 to start with. 2 times root 3 is 2 root 3. So plus 2 root 3. And 2 times root 3 is 2 root 3 again. plus root 3 times root 3, which is just 3. So this whole thing simplifies out to be 7 plus 4 root 3. So let's go ahead and write that here. So 9 is 4 plus 7 plus 4 root 3 minus 2 times 2 is 4, so minus 4 times 2 plus root 3 cosine theta. Cool. If we just bring all these constants over to this side, then we get 4 plus 7 is 11, 9 minus 11 is negative 2, so minus 2 minus 4 root 3 is equal to minus 4 times 2 plus root 3 cosine theta. So now is the part they kinda looking to examine you on, because to get the cos theta, you're gonna have to divide both sides by this constant here. And the tricky bit is that you'll have to rationalize the denominator in order to get it in this kind of a form. So if we just try that, if we just say minus 2 minus 4 root 3 divided by minus 4 2 plus root 3 is equal to cos theta, then we straight away we see that, well, we have a surd at the bottom, and that's not what they want over here. So we're gonna have to rationalize it to bring it to the top. So let's try that. If we just simplify it, we get minus 2 minus 4 root 3 divided by minus 8 minus 4 root 3. And when you're rationalizing the denominator, what you want to do is multiply both the top and the bottom by the conjugate. In this case, the conjugate is minus 8 plus 4 root 3 minus 8 plus 4 root 3, right? And you'll have to do the whole algebraic expansion, unfortunately, because this is a non-calculated question. So minus 2 times minus 8 is 16. Minus 2 times 4 root 3 is minus 8 root 3. And minus 4 root 3 times minus 8 is plus 32 root 3. Last thing, minus 4 root 3 times plus 4 root 3 is, so it's 3 times 3 and minus 4 times 4. So minus 48. Cool. On the bottom, minus 8 times minus 8 is 64. Since we're multiplying by the conjugate, you know the middle terms are going to cancel out. So minus 8 plus 4 root 3 plus minus 8 times minus 4 root 3. So that's going to be minus 32 root 3 plus 32 root 3, which is just going to be 0. So we can ignore the middle term. And the last term is the same as above. It's minus 48. And there we have it. We've got rid of the denominator. So, oh no, we've got rid of the surd in the denominator. Excuse me. So that's the hard bit done. So 64 minus 48 is just 16. And we have a rational denominator, which is pretty cool. 16 minus 48 is negative 32. And the last thing is 32 minus 8, which is 24. So plus 24 root 3 over 16. And that's pretty much it. But they want their answer in this form. A plus b root 3 over c. And actually this is completely fine as well. But if you want to just go a step further and simplify it, you could remove out the common factor of 4. So this becomes minus 8 plus 6 root 3 divided by 4. And actually you could simplify it again. Removing out the 2, you get minus 4 plus 3 root 3 divided by 2. And this is if you take out a factor of 2 from each of these terms over here. And that's it. That's the final answer. That's all it is. Yeah, I hope you found the video useful, and if you have any questions, feel free to drop a comment below. See you next time.